I'm Nick Kaddis.
And I'm Tommy Khemmoro.
I'm Marc Sessine.
I'm Alex Kaddis, and we're doing the combined gas law.
Gas law is a combination of Boyle's law, Charles' law, and Gay-Lussac's law.
It allows you to use the initial and final pressures, volumes, and temperatures to solve for a missing variable.
The combined gas law works because it's based on the idea that volume is inversely proportional to pressure and temperature is directly proportional to volume. And this is shown clearly in Charles and Boyle's law.
Let's focus on the first problem we have. The initial temperature of a 1 liter sample of argon is 20 degrees Celsius. The pressure is decreased from 720 millimeters of mercury to 360 millimeters of mercury, and the volume increases to 2.14 liters. What was the change in temperature of the argon?
In this problem, the initial pressure was 720 millimeters of mercury. The initial volume was 1 liter. The initial temperature was 293 Kelvin. The second pressure was 360 millimeters of mercury. The second volume was 2.14 liters. You're solving for the second temperature. Multiplying 293 degrees Kelvin times 360 millimeters of mercury times 2.14 liters, you get 225,727.2. And then equals 720x. You then divide by 720, and T2 comes to be 314 degrees Kelvin.
Now let's do the second question. A sample of nitrogen gas occupies a volume of 2 liters at 756 millimeters of mercury and 0 degrees Celsius. The volume increases by 2 liters and the temperature decreases to 137 Kelvin. What is the final pressure exerted on the gas?
Initial pressure is 756 mmHg. Our initial volume is 2 liters. Our initial temperature is 273 Kelvin. Our final pressure is undefined. Our final volume is 4 liters, and our final temperature is 137 Kelvin. 756 times 2 times 137, we get 207,144. And we multiply second pressure times 4 times 273, and we get P2 times 1,092. And after dividing by 1,092, it comes out to be 190 mmHg.
We'll be conducting the burning candle rising water experiment. To do so, you need certain materials. First, you need a small candle, a plate, a spoon, a cup, some water, food coloring, and a lighter.
Food coloring and the spoon. You drop 2 drops of the food coloring into the spoon, and you put it into the water, and you stir, making the water change colors.
Then you put the candle into the plate.
And then you drop the water into the plate. And that should be fine.
After that, you light the flame. Final step is to put the cup over the flame, and you wait. The flame extinguishes, and the water rises up into the cup. And there you have it.
The reason this experiment can work is because the flame of the candle makes the gas molecules in the cup expand, and then the lack of the oxygen when placing the cup over the candle causes the candle to go out, which makes the molecules contract, and the atmospheric pressure, which is greater than the pressure in the cup, moves the water from an area of high pressure to low pressure.